In this research paper titled, Enhancing Web Agents with Explicit Rollback Mechanisms, the authors from Tencent AI Lab explore how to improve web agents powered by large language models. These agents are designed to navigate and interact with dynamic web environments, but they often encounter challenges due to the ever-changing nature of websites. For instance, web pages might be removed or reorganized, leading agents to get stuck in erroneous states where their planned actions fail. The core problem is that most existing web agents use a greedy one-way search strategy. This means they proceed step by step, choosing the next action based on immediate rewards or predictions, without the ability to backtrack effectively. As a result, if the agent makes a mistake or enters an unpromising state, it struggles to recover, which can make the navigation process inefficient or unsuccessful. To address this, the authors propose enhancing web agents with an explicit rollback mechanism. This allows the agent to revert to a previous state in its navigation trajectory if it determines that the current state is erroneous or not leading toward the goal. Unlike traditional methods, this mechanism gives the model direct control over the search process, letting it decide both when to roll back and how far back to go, even multiple steps at once. Let's break this down with the figures mentioned in the paper. Figure 1 provides an overview of different search strategies. It starts with the one-way strategy, where the agent follows a linear path and might get stuck at errors. Then, it shows a best first strategy, which evaluates states based on scores and rolls back to the highest valued one, but this can lead to frequent switches and overhead. In contrast, the author's explicit rollback approach lets the model actively choose to continue or roll back based on its judgment, making it more flexible and efficient. Figure 2 illustrates the components of their enhanced web agent. It includes the environment, like a web browser, where the agent takes actions and receives observations. The agent also has a critique component to evaluate the current state and decide on rollbacks. If the agent decides to roll back, it can revert to an earlier point in the trajectory, allowing it to explore alternative paths without starting over entirely. The paper discusses why this is a significant improvement over other search algorithms. For non-interactive tasks, methods like majority voting, breadth-first search, beam search, or Monte Carlo tree search have been effective. However, these are hard to apply directly to web navigation because they often require maintaining multiple environments simultaneously, which is costly in terms of time and resources. Web navigation needs a serialized process to keep things efficient, but with the flexibility to escape errors. The authors compare their method to a recent best first search approach by Ko and colleagues, which selects the highest scored state at each step. While that helps switch to promising states, it can cause unnecessary overhead from frequent switching, especially if an intermediate state doesn't have a high score yet but could lead to the goal. The explicit rollback mechanism avoids this by letting the model make informed decisions based on the overall trajectory, reducing state switches and improving efficiency. One key feature of their strategy is that it enables multi-step rollbacks in a single operation. This is different from earlier backtracking methods for reasoning or agent tasks, which might only handle one step at a time. The paper also mentions a contemporary work by Lee and others that explores similar ideas, but the authors emphasize their method's practicality for web tasks. To evaluate their approach, the researchers conducted experiments on 2 live web navigation benchmarks. They tested it in both zero-shot settings, where the model uses no prior training on the specific task, and fine-tuning settings, where the model is adapted to the benchmarks. The results showed that the explicit rollback mechanism significantly improved the agent's performance, demonstrating higher success rates and efficiency in navigating complex web environments. Overall, this work highlights how giving web agents more control through explicit rollbacks can make them more robust and adaptable. By allowing the model to learn from mistakes and retry from strategic points, it paves the way for better handling of real-world uncertainties in web interactions. This could extend to other dynamic environments beyond the web, enhancing the reliability of AI agents in practical applications.